Hey there, in this lecture we're going to talk about end-to-end machine learning, and we're going to study different type of machine learning pipeline every data set scientists follow in industry or whenever they're working on any research project. So machine learning pipeline that is quite popular, and we're going to study how that works. So firstly we get the data, and secondly we perform EDA, which is exploratory data analysis. Then we prepare the data for machine learning algorithms. Afterwards, we select a model which is most appropriate to the given problem and we train it. Then we fine-tune our model to improve accuracy, and then we present solution. Afterwards, we launch, monitor, and maintain your system. So this is the machine learning average, most common machine learning pipeline. We get the data, we prepare the data, then we select the model, training, fine-tuning, presenting your solution, launching, monitoring, and maintaining. So we will go through this pipeline step by step to get a better idea of what we are going to study. So let's begin with exploratory data analysis, in short for EDA. So when we talk about exploratory data analysis, we should focus on the word exploratory, because that is the job, that is the first step for every data scientist. Whenever he gets the data, the next thing he does is that he starts to explore it. Like an explorer exploring hidden caves, full of questions, looking for insights, looking for clues. That's why we call it the exploratory data analysis. We have to explore the data to unravel the mysteries and gather more insights into it to data so that we can further get information before data cleaning and feature engineering. We can perform several techniques to explore that, but firstly and most importantly, we need to understand our data. So there's an EDA checklist, especially for beginners. There is some processes, some steps every data scientist should follow, especially when the first number of steps a data scientist should follow when he gets the data. But it's important to remember that EDA should be quick, efficient, and decisive. You cannot spend too much time just exploring the data, but because you need to remember that in this machine learning pipeline, every operation is dependent on the previous operation. So there's a lot of dependency management that needs to be taken care of. So you cannot spend too much time on one process. So you need to be quick, efficient, and decisive. So talking about the EDA checklist, or should I rather say the number of questions you need to ask yourself, or the number of questions you should answer by looking at the data, is what are the number of observations? The number of observations represent the total number of rows when we're talking about a tabular data in a data frame, or number of images when we're talking about image data, and so on. So the number of features should be the next question you should ask yourself. In a tabular data or in a data frame, the number of features are the number of columns, whereas in image data, then the features are their total number of dimensions of the image. Then the next question should be, what is the data type of the features? That is important because it will ultimately help us identify the type of machine learning problem we're dealing with, and the type of visualization techniques we should deploy, and many other questions. So data types of features should be very important to find out. Then we should probably find the type of problem we're solving. We should look for outliers, and we should identify any features that can be engineered. Feature engineering is the last step, and it probably takes so much time because most of the time you have to find features that have high correlation with the target variable. So on the basis which you can make your machine learning algorithm to learn on those features. Outliers are important because they can mess up your training, mess up your learning process, as we will see later on, that certain algorithms that are not much robust to outliers, and outliers can highly affect the performance and accuracy of those algorithms. So when you get the data set, the first thing you need to do is you should get a qualitative feel of the data. You should look at it to understand what type of data this is, and just a quick look so that you can get a quantitative feel, a viewpoint, quickly going through the data. So the best way to do that, if you have tabular data, is to use pandas, and after pandas you can use the pd.df.head function and visualize the first 5 rows. After this visualization, you can look at the columns, you can look out the type of data, and if possible you can also identify the target variable and the number of features we have. So this is what we call the qualitative field. So after this, looking at this, okay, so I have, this is a tabular data, I have, I guess, one particular target variable, which is the survival. And by the way, this is the Titanic survival data set, so the target variable should be the survival, and since it is only in 0 and 1, so this must be classification problem. So you see, you can find a lot of questions, you can find a lot of answers just by visualizing the first 5 rows. You also can see that in the cabin section you have a lot of missing values, which are represented by not NaN, not applicable, or not null. And there are many features that need to be engineered that are not in numerical form. And when I say numerical, it is important to remember that the computer or a machine learning algorithm can only work on or process numbers. It cannot understand words or characters. So we need to engineer these columns which have these words and characters into numbers. So then the next thing you want to find out is the data types of features. And for that we will use the pandas function of finding the data types of all the columns, and we've seen that before. And after doing that, we will categorize them into 3 different groups. The first group is that we are going to put all of the numerical data types in the numerical section, and the second group is we're going to put all the categorical into that one. And third one is that you're not sure of, but let's be honest, these are the ones which are the characters and the strings, which are going to be a problem in being processed by a machine learning algorithm, because they're not numbers. Okay, so these are the ones which we'll be working on in the future to change them into numbers or somehow extract that information out of them. The third step is that we need to plot all the numerical distributions of all the numerical data types. This is important to get more information, to study the distribution, and to understand a lot of things. So the best plot for this particular purpose is for the histograms. So the first thing you need to look out for are the outliers and abnormal distributions. In order to identify the outliers in an histogram, what we need to do is we need to look out for a bar that is not part of the entire distribution. So in this particular example, if we can find it, let's see if we can. Okay, so if you can look at the groceries feature, you can see that there is a very small bar that is to the extreme right side. Now this represents the outliers, because this is not part of the other half of the histogram that is different. There's a gap between this bar and all the other bars, so this would be an outlier. And also look at the abnormal distributions, and there are certain abnormal distributions, so be careful. Like when you use histograms to visualize categorical features, you will see that they will form bar plots. Now that is an automatic function done by histograms, and it's completely okay. That doesn't mean that there's some problem with the feature or anything. But if you want to look for abnormal distributions, now let's look at the basement feature. The basement feature only has one bar, and that is different and abnormal if you look at all the different distributions of the features. So this tells us that it only has one value that has and nothing else. So this means that this is going to be a problem for us. So you see, now you understand why plotting and visualizing numerical distributions is important. So find out outliers and to look for abnormal distributions. And we're still in the exploration phase. We're exploring, we're finding and gathering information as much as we can from the features now. So after identifying the data types, we will plot the numerical features to understand and study their distributions. The second step is to plot the categorical variables, the categorical features, to understand their distributions. And obviously they will form the bar plots. So you will get a lot of bar plots for each feature. And then we can, for now, let's just leave it be, because we will get another section where we will discuss how and why plotting the categorical distributions are important and what we can learn from them. But for now, let's focus on the bar plot technique and also the box plot technique. So in both of these techniques, we will take one particular feature and we will plot all the values in this. So now we have taken the exterior walls feature from a particular data set, and we are going to visualize the distribution, the frequency of all the different values to get a bar plot of that feature. In this one, we are actually going to study the property type feature and going to take two values, apartment or single family, and we're going to take these two categories and plot the box plot. Now from this box plot you will learn that in the apartment or condo we have a lot of outliers. Okay, so after that we also learned that the maximum value for the apartment is less than the maximum value of single value, and what other information you can get, that the median of apartment is less than the middle median of single family, and so on. You can gather a lot of information from these box plots as well. So the important thing over here is that you need to understand in this particular box plot we are actually visualizing two different features. We are visualizing the property type against the TX price. So we are trying to understand what is the relationship between the type of property and their price. Now in this way we can understand a lot of things, and we will ultimately learn so much about the two variables. In the previous example of bar plots, we just were actually concerned with the distribution, the frequency of those values. In this one we want to understand the relationship between the property type and TX price. So you can use different plotting techniques and visualizing techniques like multivariate visualization in this scenario or univariate visualization in the previous scenario, and stuff like that, to gather as much information as you can. So basically all of these types of processes depend on the type of questions you're asking yourself. So if you want to study what is the relationship between the price and the property type, you will use this particular multivariate visualization or any other technique of multivariate visualization. So it's always depending on your domain, your type of questions you ask, and what you want to explore. The third univariate, or you can say the multivariate visualization, is the correlation matrix, and we have studied this many times in statistics and visualization techniques. And now in machine learning we need to find, in order to study the relationship of all the variables with the other variables or features, I may call it, we need to study them, and we need to look which of the features have the maximum value and with the positive number, positive maximum values. In this way we're looking for features which have high correlation with one another, but most importantly which have high correlation with the target variable. So we will select those features, and we will see in feature engineering that we will, after selecting those features, we will train our machine learning algorithm on those features, because those are the only features which are contributing to the target value. So if we're talking about the price of the house, and the only features that are actually contributing or determining the price are the size of the house, the number of bedrooms, and the location of where the house is located. The rest of the features, just like name or street number, index number, and stuff like that, that are not actually contributing to the price, and they have nothing to do with it. So that's why correlations and correlation metrics are used in multivariate visualization are very important.